In this tutorial, we will continue with solving exercises where we have to solve an equation of the form a to the power x equal to b. Now in the previous tutorial, we have solved example 8. What's going to happen now is that we're going to solve another example similar to the concept that we were working with in the previous tutorial where we have introduced the log. Now we're going to solve example 9 in this tutorial. It says solve the equation 7 to the power x plus 1 equal to 3 to the power x plus 2, giving your answer to 4 decimal places. And so what's going to happen is that we're going to use the same exact idea that we have used in exercise 8. But example 9 is a bit more complex since you can notice right here the power is x plus 1 and x plus 2, where in the previous tutorial it was just x. Still, it is a bit more complicated but has a couple of extra steps. Here we have our first term 7 to the power x plus 1 equal to 3 to the power x plus 2. What we did in the previous tutorial is that we introduced log 10. What's going to happen is that we're going to introduce them again, as you can see here. Also on the other side of the equal, introduce log 10. Now it is a bit more easier to solve. Now what's going to happen is that we're going to have to change the form of the whole equation. And so the exponent x plus 1 is going to become a coefficient to log 10, as we have learned in the logarithm laws. Same for the other side of the equal, x plus 2, log 10, 3. And so this is basically how it's going to be. Now what's going to happen is that we're going to have to expand the x and the plus 1 into log 7 with base 10. And so this is how it's going to look like. Also expand plus 1. And so we're going to have x log 3 with base 10. And also plus 2. And this is done for expanding. Now that we are done with expanding, there is an extra step that you're going to have to make. Notice that we have x log 3 and x log 7 on either side of the equal. So why not isolate them on the left side of the equal as I'm doing right now? And also the sign of log 3 is going to switch. And of course, on the other side of the equal, we're going to have 2 log 3 with base 10 minus log 7 base 10. Now moving on, we're going to factorize and extract the x, leaving log 7 with base 10 minus log 3 with base 10 equal to, here on the other side of the equal, what's going to happen is that we're going to have to work with the coefficient that we have. And so it's going to be log 9 base 10 minus log 7 base 10. Now, what's left off is to change this into fraction form. X equal to log 9 base 10 minus log 7 base 10, all divided by log 7 base 10 minus log 3 base 10. Now, the following step is going to be using the calculator. You're going to have to calculate the whole fraction. We have log 9 minus log 7, and that would be for the numerator. Again, the log on the calculator is automatically base 10. So log 9 minus log 7 divided by log 7 minus log 3. And so the final answer is as follows: 0.2966606, etc. But the question already asked us to give the answer correct to 4 decimal places. And so it's going to be 0.2966. And that would be the value of x. X is equal to 0.2966. And that would be the final answer for this equation. So a quick recap, what we did is that we introduced the log. After that, we worked on expanding the coefficients. After expanding, we did some factorization in order to isolate the variable x, the variable that we are trying to find out, and then we worked with the calculator. And so as you can see here, this is basically a brief explanation about how to work with what we have done previously in this video. you have seen how we have used the power of law, and then we multiplied out, then we collected the x terms, and finally factorized and divided using the calculator, and we managed to find the value of x in this equation, and that would be 0.2966. Now, I recommend you solve exercise 3E1 on page 46, where you're going to have to use the same exact method in order to learn more.